All right, the last thing we're going to look at here in chapter 1 is accuracy and precision. So these may seem like they have the same meaning. However, accuracy refers to the closeness to the true value, whereas precision refers to the consistency. Accuracy is a lot about, how well is the instrument actually getting the known value. And this may come through averaging a lot of things. But precision is how consistent is the tool measuring, right? I think a good example is that when I was a kid and I would play baseball with the neighborhood kids, we knew that it was supposed to be like 60 feet between the bases, whatever is what we wanted. But we didn't bring tape measures. We just paced it out, right? We just walked it with our feet. And we got to about 60 feet, right? It's about 20 paces. But that's not that precise. However, it was good enough, right? The precision is not there because different kids, different strides, different, amounts of energy to get your stride there. It's not to say that an imprecise measurement is just bad. It's to say that we need to understand the level of precision within our instrument because it's only with precise instruments that we're going to get really accurate results. When we think about my baseball setup as a kid, right? When we're pacing out 20 steps, we might end up getting, 55 feet, 62 feet, 49 feet. Who knows? We probably won't get 5 feet, though. I don't think any kid is going to fit 20 paces into 5 feet. And so, in the end, though, it didn't really matter that much, right? There's still about the distance we wanted, and we didn't require a high degree of accuracy for that problem. The precision wasn't limiting our result, even though in the end, if we actually checked how far those bases were, we probably didn't get that close to the actual value. When you need a really accurate result, when you cannot tolerate much difference from the value that you want, it's important to have precise instruments to measure it consistently. Okay, let's take a look at a clinical scenario. So if a patient is just prescribed 5 milliliters of a liquid medication, and we have a few measurements that were done here, right? Nurse A is looking at the measurement, and they measured 4.98, 5.02, 5.00 milliliters, right? They have hundredths of a milliliter that they are looking at, and this is what the nurse measured. Nurse B measured 4.60, 4.61, 4.59, and Nurse C measured 4.20, 5.80, 5.10 milliliter. What do we think about these different measurements, right? Who did what well? Well, let's say that the amount that we want is 5.0 milliliters. We would say that Nurse A measured both accurately and precisely. I think this is good precision, right? This is hundredths of a milliliter. That's a really small amount. And if we average those, it's going to be 5.00. Nurse B did measure precisely, but is not getting the right answer. That's not accurate. There's precise measurements, but it's not really accurate. And finally, Nurse C is measuring imprecisely. And somehow Nurse C has made for an average measurement that is pretty close to what we have desired. However, the idea that this could be accurate in spite of being imprecise really doesn't work. If the measurement is this imprecise, it's really hard to trust the accuracy. Okay, so right, let's kind of review that. I know that I discussed it previously, but I would recommend writing that up again, right? What did we discuss, right? Nurse A, Nurse B, Nurse C. Which is the most accurate? Which is the most precise? Which shows the greatest amount of random error? Consider these questions a little bit, and then I'll share my 2 cents. Remember that precision without accuracy is really dangerous, but also being imprecise is dangerous as well. It's very important that we are precise and accurate. This is not just like when I was pacing out, baseball base paths, right? We care in nursing whether it's 4 milliliters or 6 milliliters, even though, in other examples, you might not. It's just the nature of your measurement. But in healthcare, we really do want to be accurate and precise to a greater degree than what I described earlier. Nurse A is the most accurate and is precise. Nurse B is, I guess, precise, but inaccurate. Nurse B is doing something fundamentally wrong with how the nurse is measuring these values, and that is showing an inaccuracy, right? There's some sort of systematic way that Nurse B is measuring incorrectly, although the nurse is doing the same thing each time. And Nurse C has a lot of random error. Okay, again, this is sort of the final thing that we want to talk about with error because we have a couple different types of error. There's a systematic error. So maybe nurse B previously, doesn't understand where the line is supposed to be read on the on the whatever the measuring device is, right? That's some kind of a systematic error, right? And it's being read the same every time, but systematically incorrectly. That's a problem, right? And it's going to affect the accuracy, even though the repetition of each one will be showing that it's a precise measurement. Random error is unpredictable. So that's like nurse C. Nurse C might have forgotten their glasses and is just kind of doing their best, right? 5.8, 5.1, 6.2. That's not good either. That's totally random and can be unpredictable. Poor precision may end up getting good accuracy, but highly unlikely that that would work out. A couple of examples here. Miscalibrated IV pump. What type of error is this? Is this systematic or random? Measuring hurriedly. Is this systematic or random? Consider that for a second, and then I'll sort of wrap up. Both of these errors are going to be able to harm patients, but which one is particularly dangerous if unnoticed? I would say here that, I'm not sure, right? Which is particularly dangerous if unnoticed? They're both pretty bad, right? Miscalibrated IV pump, this is going to be getting the wrong value every single time. Measuring hurriedly, this, I guess, might get the wrong value, probably will get the wrong value. I guess the miscalibration is considered more dangerous, but, because it kind of gives the guise of being okay. The miscalibrated IV pump, this is systematic error. Measuring hurriedly, this is random error, right? Both will affect your accuracy. We cannot have accuracy without good precision. And while the miscalibrated IV pump might show good precision, we need it to both be precise and accurate. It has to be calibrated so it's getting the right answer and then show that the instrument is good enough to get the same answer, the correct answer every single time.